Hey guys, what's up? Welcome back to the classroom. It's Mr. Low. Alright, and today we are gonna finish up on page 5 and 6 of the notes. Okay, in this case, the topic here is expressing two or more ratios as one single ratio. Okay, let's look at the first example here. Okay, we are given A is to B is 2 is to 3, and B is to C is 3 is to 5. And we are told to express the three quantities in a single ratio. A is to B is to C. So how do we do this? Well, first of all, when we look at A is to B and B is to C, we see that the common quantity here is B. B is in common. Okay, is in common. So we can try to combine AB is to BC. So A is to B and B is to C into one ratio, but only if the the number for B is the same for both sides. What do I mean by that? Okay, let's look over here. A is to B, B is 3 units. Okay, is expressed in 3 units. And over here on the right hand side, B is to C, B is also given written is in 3 units. So since this is the same number for both sides, we can immediately go ahead and combine. A is to B is to C is 2 is to 3 is to 5. No problem. However, if B, the number of units for B in on the left hand side and on the right hand side is not the same, then we cannot immediately do that. Example 2 shows us an example. Again, B is in common between the two ratios, the two given ratios. But you realize that on the left hand side, B is represented by 4 units. But on the right hand side, B is represented by 2 units. They are not the same. So what can we do here? What should we do here? Well, we should actually make the two B's be represented by the same number of units. So let's compare them side by side. Okay, we have 3 is to 4 and 2 is to 7. Well, one thing I can do is on the right hand side, I can express B in 4 units by multiplying the ratio, both sides of the ratio by 2. So now I have the same representation, 4 units on both sides. Okay, once this is done, I can then go ahead and combine the ratios, the two ratios into one. 3 is to 4 is to 14. So I did this on the right hand side. I multiply both sides by 2 so that for B, 2 turns into 4. So that I have the same number of units as representation on both sides. So this is something you have to do if B is not represented by the same number of units in both the ratios. So to sum it up, okay, take a look at what I've written here. Okay, when it comes to this kind of problems, to combine two ratios into one, right, you have to ask yourself, is the common item, the common quantity, in this case B, okay, written in the same number of units for both sides? If yes, just go ahead and combine. If not, then you have to make sure that the left hand side and the right hand side, okay, the B are represented using the same number or represented by the same number of units. Let's check our understanding with practice 3. In practice 3, we realize that, okay, again, B is in common. Okay, it's common for both ratios, but one is on the left hand side 4 units and on the right hand side 3 units. They are clearly not the same. Sorry, on the left hand side is not 4 units but 5 units. Yeah, so on the left hand side, we have 5 units, and on the right hand side is 3 units. They are not the same, 5 and 3. So no choice over here. We have to make them the same number. So how do we do that? Well, we do that by finding first the common multiple of 5 and 3. Okay, and we choose in this case the lowest common multiple, which is 15. So um, so we make both the numbers 5 and 3, we turn them into 15, okay, in both the ratios. And how do we do that? Over here, we multiply by 5. So for A, we also multiply by 5. Okay, for the second ratio on the right hand side, 3 is multiplied by 5 to give us 15, and so does 7 must be multiplied by 5. So now, as a result, you have a common number for B in both the ratios. Once I've achieved that, I can immediately go and combine the three quantities into one single ratio. A is to B is to C. And we are done for this. Alright, next we come to word problems or real world context problems. Okay, so the usual way to go and tackle this kind of question is, well, I'm going to read the question carefully and then take down notes as you read. So in this example 1.1, the two girls, Daisy and Elaine, they went shopping. Right? Daisy spent $55 while Elaine spent $75. The question asks for the ratio of Daisy's expenditure to Elaine's expenditure. In case you're not too sure what expenditure means, all right, it also means spending. So the question asks, what is the ratio of Daisy's spending is to Elaine's spending? Well, first thing, we know that Daisy spent $55, Elaine spent 75. So we can immediately go and write down the ratio. So I write down Daisy is to Elaine, 55 is to 75. Okay, over here, there is no need to write $sign here, even though you may be aware that the quantities are in dollars. Okay, but remember, in a ratio, there is no need for units. Either way, they are the same units, dollars. So there's no need to write it down. Okay, from here to here, remember we must express our ratio in the simplest form. So we divide both sides by 5. Okay, so we divide both sides by 5 to give us 11 is to 15. And we are done. Next, example 1.2. Okay, example 1.2 is extremely difficult. In fact, the next one is even more difficult. Okay, so let's take a look here. Okay, Sally wants to make a mixture, okay, consisting of liquid A and B. Okay, to obtain one mixture, Sally has to mix 3/4 teaspoon of A, and then he has to mix it with 1.5 teaspoons of B. Now remember I said that I hate mixed fraction. So immediately I will convert 1.5 to 3/2. So as I read the question, I will take notes by the side. So part A asks for the ratio of liquid A is to B. So I simply have to write it down because they are both in the units of teaspoons. I don't need to worry about units. There's no need to convert. Okay, so 3/4 is to 3/2. Okay, I simplify the ratios, right, by multiplying by 4. Okay, remember when you see a fraction, I want to multiply both sides by the lowest common multiple of 4 and 2 in this case, which is 4. Then I further simplify the ratio to 1 is to 2. And we're done for this part A. Part B asks for the number of teaspoons of B needed if if Sally has 6 teaspoons of liquid A. Now the beauty about this thing called this ratio thing is that I don't need to care about the actual number. In this case, we need to care about the actual number now because it is told to us specifically that there is 6 teaspoons of A, and we are tasked to find exactly how many teaspoons of B should be mixed together. Okay, so how do we do this? We go back to the ratio again. Okay, we obtained 1:2 from the previous question here, the previous part. Okay, there are two ways to approach this. Okay, one, we see that Sally added 6 teaspoons of liquid A. So let me force liquid A to the ratio of 6. 6 over here, right? So just nice, I can multiply both sides by 6 to give me 6:12. So immediately, if I have 6 teaspoons of A, how many teaspoons of B do I have? Or rather, how many teaspoons of B should Sally include? Immediately, we can just read off 12 teaspoons and we're done. Okay, so Sally needs 12 teaspoons of B. Second method, some of you like to have units, like to write things in units. For instance, over here, 1 unit represents 6 teaspoons because the ratio, remember the ratio of A is to B is 1:2. So therefore, 1 unit represents 6 teaspoons. And then how many teaspoons are there for B? Well, liquid B is 2 units in the ratio of 1:2. So 2 units represents 12 teaspoons. And we are done. So Sally needs 12 teaspoons of liquid B. Remember to have this concluding statement here. Very important. Okay, so this is done in using units. Okay, so method 1, I change the ratio to get the number that I want. Method 2, you go by number of units. It is the same. Okay, we move on to the, I believe it's the last question. No, that's not the last question. Okay. Example 1.7. Okay, so a certain shoe shop offers 3 brands. Okay, we have A, B, and C. Okay, the ratio of A to B is 2:3, while B to C is 4:5. Okay, so this reminds us of the question before. This kind, we are given A is to B and B is to C separately. Okay, so let's tackle this question. Okay, so we write down just as before. A is to B and then B is to C. 2:3, 4:5. The question asks, what is the ratio of A is to B is to C? So again, we have to combine the two ratios separately into one. So we realize that brand B is in common, but the numbers represented on both sides is not the same. One is 3, the other one is 4. So we find a lowest common multiple. In this case, we get 12. Okay, 12 is the common multiple of 3 and 4. So for the left hand side, it is multiplied by 4. So does the other side. On the right hand side, it's multiplied by 3. Okay, now that we have obtained the same number of units for brand B in both ratios, I can go ahead and combine them. 8:12 is to 15. And we're done. For part A. Okay, part B says, if there are 24 pairs of A, how many pairs of C are there? Well, we have already obtained the ratio A is to B is to C. So we can compare the number of units. So let's take a look. In the ratio given found in part A, it is 8 is to 12 is to 15. So A is represented by 8 units and C is represented by 15 units. Right? Since there are 24 pairs of A, we have 8 units is 24 pairs. And we're interested in finding 15 units for C. All right. So I take 24 divided by 8. That gives me how many pairs of shoes per unit? You multiply by 15. Okay, that gives me 45 pairs. And we're done. Part C. How many pairs of shoes were offered for sale? This question is trying to ask us how many pairs of shoes are there for A and B and C combined together. Okay, so all we have to do is, again, using the same ratio found in part A, 8 is to 12 is to 15, we can find how many units of shoes are there altogether. 8 plus 12 plus 15, that gives us 35. Okay, 35 units. Well, since each unit is represented by 3 pairs, as we have seen in part B, the total number of pairs is simply 35 units times 3 pairs. And we have 105. And we're done. Okay, we're coming down to the last question here before the next part of the notes of the chapter. Okay, this question is extremely difficult. Let's tackle this question slowly. Okay, we have this girl Li Ting who wants to buy 500 milliliter bottles of concentrated washing detergent. Okay, so if you're not too sure of what this thing is saying, ultra concentrated washing detergent, think of it as Ribena. Okay, some of you might have tried this before. When you buy a bottle of Ribena, you have to mix it with water. If not, it will be too sweet. That thing that you mix with water, that Ribena there, is the concentrated version. You have to dilute it with water, right? If not, it'll be too sweet. In this case, it's the same. The washing detergent is too concentrated. It's not suitable to use directly for washing, okay? And so you have to mix it with water. So what does the instructions on the bottle say? You have to mix 1 part of detergent to 4 parts of water. Okay, so immediately we can write down the ratio already. Detergent is to water is 1 is to 4. Okay, so I can take the notes by the side. Okay, so part 1 asks, if Li Ting wants to make 5 liters of washing solution, this solution here is not just the detergent itself, not just the concentrated detergent, but it is the mixture of detergent plus water mixed together. When she mixes them together, she wants to have a total of 5 liters. 5 liters of detergent plus water. Using the ratio that is suggested by the manufacturer. So find the number of bottles of this concentrated washing detergent she has to buy in order to make 5 liters of mixture of this solution. And you must remember in the previous part of the question says the bottles come in 500 milliliters size. Okay, so let's see how to do this question. First, I will write down the ratio 1 is to 4. Okay, as we seen just now. Okay, so from 1 is to 4, we can tell that in a standard mixture, there are 5 units. Okay, 1 unit comes from detergent and 4 units comes from water. Okay, now she wants to make 5 liters of solution, and the concentrated bottle comes in 500 milliliters size. Clearly, the 2 units are different. We must convert. Okay, so if you recall, 1 liter is 1000 milliliters. She wants to make 5 liters of solution. That means in total, she should have 5,000 milliliters of detergent and water combined together. Okay, so how many units is that? Well, it's simply 1 plus 4 as we discussed just now. 1 part detergent, 4 part water, 5 units. So now, if she wants to make 5 liters or 5,000 ml of solution, then these 5 units will now represent 5,000 milliliters. So if she wants to make 5,000 milliliters of solution, then 5 units now represents 5,000 milliliters. And the question asks, how much, or rather how many bottles of the concentrated detergent she needs to buy? First, we have to figure out how much of that concentrated detergent she needs in order to figure out how many bottles she needs to buy. So in the ratio 1:4, you need 1 unit of the concentrated detergent. Therefore, I find 1 unit, okay, being 1000 milliliters. So therefore, I need 1000 milliliters of the concentrated version of the detergent. I need to buy this much. So how many bottles is needed? Well, it's just 1000 divided by 500 milliliters, because each bottle comes in 500 milliliter size, and I get the answer of 2. So Li Ting needs to buy 2 bottles, okay, of the concentrated solution in order to make a 5-liter mixture. So it looks something like this, okay. 1 big bottle of the detergent concentrated is 500 ml, and for the recommended mixture, okay, recommended mixture here, you need 4 part water, 1 part detergent. And by saying 4 part and 1 part, I did not specify the exact volume. So from the question, you can tell it depends on how much, what is the volume of the mixture you want to make. Then you have to go and do the calculation. All right. Okay, I hope this is fine. Let's move on to part 2. Okay, using the number of bottles bought in part 1, which is 2. So let me write it down immediately. 2 bottles. Okay, Li Ting decided to make an even more diluted solution than suggested. What does it mean? What does it mean by even a more dilute washing solution than suggested? Dilute means more water. So in the suggested ratio is 1:4. Okay, 1:4, as we've seen above, 1:4. Now she wants to make a solution that is even more water, that has even more water content than the recommended 1:4. So that means she's thinking of a ratio of, for instance, 1:6 or 1:10. More water content, okay, than the suggested one. Okay, so what is the ratio? That one we don't know. What is the ratio? We have no idea. So chances are we need to use algebra now. 1 part detergent is to X parts of water. And we know from here that X must be bigger than 4, because she wants more water content. Okay, so next, if she makes 10 liters of washing solution, 10 liters of washing solution, what is the mixing ratio she should use instead? All right, so again, this washing solution is detergent plus water. Okay, detergent plus water. So let's see, how do we approach this? Okay. Yeah. So we don't know how many parts of water is to be mixed. That she wants to mix with 1 part of detergent, so let's call it X. Okay, so this this statement here very important. Let x be the ratio such that is 1 is to x. Okay, now how many total units now do we have? Well, it's simply 1 plus x. Just now it was 1 plus 4, now it's 1 plus x. Okay, so now this total number of units 1 plus x represents how many milliliters? Just now it represents 5 liters or 5,000 milliliters. Now she wants to make 10 liters, which is equivalent to 10,000 milliliters. So now 1 plus x units will represent 10,000 milliliters. If you're not too sure, you can compare to the previous part, how we do it when she wants to make 5 liters. Okay, the method is the same. So now, just like before, we need to find what is the volume for 1 unit. Okay, 1 unit is simply 10,000 divided by x plus 1, or 1 plus x, or 1 plus x. It's the same. Okay, so I just divide both sides by 1 plus x. Okay, so now 1 unit represents this much milliliters of solution. Next, we know from the previous part that since she bought 1000 milliliters of the detergent, the concentrated one, remember that's 2 bottles, and the ratio for detergent is to water now is 1 is to x. 1 unit of detergent now represents 1000 milliliters because she bought 2 bottles, 1000 milliliters. Okay, so we have this piece of information. Therefore, this is 1 unit. Okay, 1 unit over here equals to 1000 milliliters. What we have to do now, once we come to this step, we realize that there's an x here. It is clear that we need to solve for x. So how do I do that? Well, I cross multiply this thing up, and 1 I cross multiply up. And in the end, I have 10,000 equals to, okay, if you're not too sure how I arrive here, when I cross multiply up, I have 1000 times x plus 1. So I do the rainbow method. Okay, to open up the bracket, I have 1000 x plus 1000. And I'm interested in solving for x, which is over here. So we do the usual. Okay, I see there's a 1000 here. I need to move over. Okay, 1000 plus 1000 move over becomes minus 1000. Okay, then I get 9000. 1000x is 9000. 1x is simply 9. So we have found x. And the question asks for what is the mixing ratio now that she wants. Well, we said that the ratio was 1 is to x. Now we found x equals to 9. So we simply put it in 1 is to 9. And you can check that indeed x is bigger than 4. She put in more units of water than suggested by the bottle. Alright, I know this question is a bit difficult. Okay, once you have taken down all the answers, please look through again to see whether the answer makes sense to you. I think the difficult part is here when you deal with the algebra. Okay, please check again. If you have any questions, feel free to contact me. Okay, thank you very much for watching. Have a good day.